Welcome back in lecture series on topic electrochemistry. In last video, we have studied how mass of substance deposited at an electrode is related to quantity of electricity passed through the cell and steps involved in calculation of mass of substance deposited during electrolysis. And today in this video, we will solve numericals based on the mass of substance deposited and quantity of electricity. And to solve these numerical problem, we must know some important formulas. So let us see that important formulas. First, that is quantity of electricity passed during electrolysis. So if you want to calculate quantity of electricity, then you have to use this formula, that is Q is equal to I into T. Remember here that T must be in second if you want to calculate quantity in coulombs. So Q is equal to I into T. Second formula, that is if you want to calculate the mass of substance deposited, and if I is given, T is given, then from that first you have to calculate Q and then moles of electron actually passed, and that is equal to Q divided by 96,500 coulombs. So this formula will give you the moles of electron actually passed, and from that we can calculate here the mole ratio. To calculate the moles of product form, you must know the mole ratio, and for that you have to write the half cell reaction, stoichiometry of half cell reaction, and from that you can calculate easily mole ratio, that is moles of product formed in half reaction divided by moles of electron required in half reaction. Using this formula you can calculate mole ratio, and from mole ratio we can calculate moles of product formed using this formula, Q divided by 96,500 into mole ratio. This will give you moles of product form. And if you know the moles of product, then you can calculate mass of product. That is Q divided by 96,500 into mole ratio into molar mass. M, capital M means molar mass of the product, that will give you W, that is mass of product. So like this you can calculate mass of product in 4 different steps. And if the two electrolytes, different electrolytes, if they are connected in series, then also you can find out the mass of the substance, because the mass of the substance deposited at the respective electrode, they are related with this formula, with this relation, and therefore you can calculate the mass of the other substance deposited in another electrolytic cell using this formula, that is W1 divided by mole ratio of 1 into molar mass of the first substance is equal to W2 divided by mole ratio of the second substance into the molar mass of the second substance. And if the question is asked like this, that is how much electricity in terms of Faraday is required to deposit a particular substance for 20 gram or x gram of a substance, then you can use this relation, that is 1 Faraday is equal to 96,500, and that corresponds to the charge of 1 mole of electron. And using this relation you can calculate what the quantity of electricity in Faraday is required to deposit a particular grams of the x grams of the substance. So for that you must know this relation like this. For example, if monovalent cations are there, then such as sodium plus 1, potassium plus 1, Ag plus 1, and if they deposit, from that you have to deposit sodium, potassium or silver, then you know this reaction, it is a reduction reaction. Sodium ion takes up 1 electron and forms sodium atom, and the mole ratio of this is what? 1, because here number of moles required is 1 to deposit 1 mole of sodium, that is 23 grams of sodium. The 1 mole of electron is required, that means 1 mole of electron is equal to 1 Faraday. So to deposit 1 mole of sodium, 1 Faraday of electricity is required. Like that, if the divalent cations are there, copper ions, zinc ions, means copper plus 2, zinc plus 2, Mg plus 2, calcium plus 2, like this, then these divalent cation accept 2 electrons. They require 2 moles of electron to deposit 1 mole of the divalent substance. So here it is an example of copper. Copper plus 2 ions requires 2 moles of electron to deposit 1 mole of copper. That means 63.5 grams of copper. That is a molar mass. So and that means what? 2 Faraday of electricity is required to deposit 1 mole of copper, and therefore mole ratio is 1/2. If trivalent cations are there, such as aluminium ion, Fe ion, chromium ion, or gold, that is Au plus 3, then they accept 3 electrons to deposit 1 mole of the substance. Aluminium plus 3, when accept 3 moles of electron, then it gives you what? 1 mole of aluminium, and 1 mole of aluminium means 27 gram, that is molar mass of aluminium. So to deposit 1 mole of aluminium, 3 moles of electrons are required. That means 3 Faraday of electricity is required to deposit 1 mole of aluminium. So mole ratio is 1/3. So if you know these relations, then you can solve the numericals based on this relation. So we will see here first, that is the problem which is in your textbook, that is how many moles of electron are passed when 0.8 ampere current is passed for 1 hour through the molten calcium chloride. Now what is given here? Current is given, that is I is equal to 0.8 ampere. Also time is given, but it is in hours, that is 1 hour. So you have to convert that 1 hour into seconds. So 1 into 60 into 60, 60 minutes into 60 seconds, that is equal to 3600, 3600 seconds. And what you have to calculate? Moles of electron passed. How many moles of electrons are passed? That is asked. So formula for that, Q is equal to I into T. I is given, T is given. So substitute these values, and you have to calculate what? The moles of electron pass. And for that moles of electron, you have to calculate Q, and then Q divided by 96,500. That will give you moles of electrons pass. So we will substitute these values. Current is given, that is 0.8 ampere. Time is also given, that is 1 hour, that is 3600. So substitute this 0.8 into 3600. That is if you calculate it by log, then log of 0.8 plus log of 3600, and that is equal to log of 0.8 is bar 1.9031, and log of 3600 is 3.5563. So if you add these two, then it is equal to how much? 3.4594. So antilog of the 0.4594 is 2880. Here characteristic is 3. So you have to put the decimal point here. So 2880. So substitute this. And so here Q is equal to how much? 2880 coulombs of electricity is required. Now you have to calculate moles of electron. Therefore moles of electron passed is equal to Q divided by 96,500. So Q is equal to 2880 coulombs. So substitute this value in the formula. 2880 divided by 96,500. That is nothing but log of 2880 minus log of 96,500. That is log of 2880 is 3.4594, and log of minus log of 96,500 is 4.9845. So subtract this, you will get what? Bar 2.4749. So antilog of 0.4749 is 0.2985, but here characteristic is bar 2. So you have to put decimal point here, 0.02985. So your answer is how much? The moles of electron pass is equal to 0.02985 moles of electron. So moles of electron pass through the molten calcium chloride is equal to how much? 0.02985. This much moles of electrons are passed. So like this you can solve the problem based on this formula. Then second problem, see here, what current strength? Now here I is asked, what current strength in ampere will be required to produce 2.4 gram of copper from copper sulfate solution in 1 hour? Time is also given. Molar mass is also given. Molar mass of copper is 63.5 gram per mole. So using this we have to solve we have to calculate what? Current strength. Mass of copper is given 2.4 gram. Time is equal to 1 hour, that is 3600 seconds. And molar mass of copper is also given 63.5. Now what you have to calculate? Current strength in amperes, that is I. And for that you have to use this formula, that is W is equal to I into T divided by 96,500 into mole ratio into mass, molar mass. So rearrange this equation. Therefore I is equal to W into 96,500 divided by T into mole ratio into molar mass. Using this formula we can calculate the current strength, that is I. So substitute the values in this formula. Mass of copper W is equal to 2.4 gram, T is equal to 3600 and M is equal to, that is molar mass is equal to 63.5. So if you substitute here, you have to calculate what? The mole ratio, and for that mole ratio you have to write what? The formula, that is a stoichiometric half reaction, that is reduction reaction. So copper plus 2 aqueous, when it accepts 2 electron, then it deposit 1 mole of copper, and therefore here mole ratio for this half reaction is half, that is 0.5. So mole ratio is equal to how much? 0.5. So here 2 moles of electrons are required for 1 mole of copper. Here copper is a product, moles of product is 1, moles of electron required is 2 moles. So 1 by 2, that is equal to 0.5. Now substitute these values. I is equal to 2.4 into 96,500 divided by T 3600 into mole ratio 0.5 into 63.5. So here 0 cancel, so 2.4 into 965 divided by 36 into 0.5 into 63.5, that is here log of 2.4 plus log of 965 minus log of 36 plus log of 0.5 plus log of 63.5, and this log of 2.4 is 0.3802 plus log of 965 is 2.9845 minus log of 36 is 1.5563 and log of 5 is bar 1.6990. Log of 63.5 is 1.8028. So here if you add these two, then it becomes how much? 3.3647, and if you add all these three, then the addition is 3.30581. If you subtract these two, then you will get 0.3066. So antilog of 0.3066 is 2.026. So current is how much? Therefore I is equal to 2.026 ampere. So current strength in ampere is equal to how much? 2.026 ampere. So like this you can calculate current strength. Problem number 3, see here. In certain electrolysis experiment, 4.36 gram of zinc is deposited in one cell containing zinc sulfate solution. Calculate the mass of aluminium deposited in another cell containing LCl3 solution connected in series with zinc sulfate cell. Now here this is a problem based on Faraday's second law, that is what the two different electrolytes are there, that is zinc sulfate and aluminium chloride, and these two electrolytes or cells, electrolytic cells, are connected in series and same quantity of electricity is passed through both these electrolytic cell. Then in one cell, that is in which zinc sulfate is there, 4.36 gram of zinc is deposited, and from that you have to calculate the mass of aluminium deposited in another cell. And what is given? Molar mass of zinc is given 65.5. Aluminium is also given 27 grams per mole, and you have to calculate the mass of aluminium. What is given? Mass of zinc, W1 is given 4.36 gram. Molar mass, that is M1, is given 65.5. Molar mass of another substance is also given, that is M2 is given 27 gram, and you have to calculate mass of aluminium, that is W2 you have to calculate in this numerical problem. So we have to use the formula W1 divided by mole ratio of zinc, that is reduction reaction of zinc, into molar mass of zinc is equal to W2 divided by mole ratio of the second, that is aluminium, into M2, that is molar mass of aluminium. W1 is 4.36 gram, M1 is 65.5, M2 is 27 gram, and if you substitute these two, then you have to first calculate what? The mole ratio of the zinc, reduction of zinc, and mole ratio of reduction of aluminium. So mole ratio of zinc is like this: zinc plus 2 ion, when accept 2 electron, then it gives you zinc. That means what? Mole ratio of product, moles of product is 1 and moles of electron require 2. So 1 by 2 is the mole ratio. Like that, aluminium plus 3, it is a trivalent ion. So aluminium plus 3 accept 3 moles of electron and deposit 1 mole of aluminium, and therefore mole ratio is 1 by 3. So if you substitute these values in this above formula, 4.36 divided by 1 by 2 into 65.5 is equal to W2 divided by 1 by 3 into 27. That is equal to W2 is equal to 4.36 into 1 by 3 into 27 is divided by 1 by 2 into 65.5, and that is equal to 4.36 into 9. 1 by 3 into 27 means 9, and 1 by 2 into 65.5 is 32.7. So if you take log of this, that is log of 4.36 plus log of 9 minus log of 32.7, then log of 4.36 is 0.6395 and log of 9 is 0.9542 minus log of 32.7 is 1.5145. So addition of these two is 1.5937 minus 1.5145. The subtraction is 0.0792 and antilog of this 07 is 1.200. So mass of aluminium deposited in another cell is how much? 1.2 grams. So if you know, if two electrolytic cells are connected in series and if you know the mass of one substance, then you can calculate the mass of another substance. Here the masses of this substance are different one. That is, mass of aluminium is 1.2 and mass of zinc is 4.36. Though a same quantity of electricity is passed through the both the electrolyte cell which are connected in series. That means it depends upon the element, that is mass, substance which is deposited, its valency, it depends upon the mole ratio of the substance deposited. So mass of and molar mass. So you can calculate the mass of the another substance which are connected in series. Another problem, that is how much, this is slightly different type of a problem. Many times questions asked on this in MCQ. So prepare these problems, such a type of a problem well. See here, how much electricity in terms of Faraday is required to produce 20 gram of calcium from molten calcium chloride, and second, that is 40 gram of aluminium from molten Al2O3. And what is given? Molar mass of calcium is 40 gram per mole and aluminium is 27 gram per mole, that is given. Now from this you have to calculate what? Electricity required to produce 20 gram of calcium and 40 gram of aluminium. So molar mass of calcium is given, molar mass of aluminium is given, and you have to calculate electricity in Faraday to produce 20 gram of calcium and 40 gram of aluminium. So 20 gram of aluminium, 20 gram of calcium from molten calcium, to deposit this much quantity, how much Faradays are required, that you have to calculate. So molar mass of calcium is 40 gram, and the half cell reaction is what? Calcium plus 2 in the liquid form when accept 2 moles of electron and deposit 1 mole of calcium in a solid state. Therefore the mole ratio for this is half. That means 1 mole of calcium, that is 40, 1 molar mass of calcium is 40. So 1 mole of calcium, that means 40 gram of calcium requires how many moles? 2 moles of electron. This reaction shows that, stoichiometry of this half reaction shows that what? To deposit 40 grams of calcium, 2 moles of electrons are required. Then simple, very simple problem, then that means 2 Faraday of electricity. Therefore 20 grams of calcium requires how many Faraday? Such a type of problems are asked in MCQ. So 40 gram corresponds to 2 Faraday. Therefore 20 grams corresponds to how many Faraday? 2 into 20 divided by 40, that is equal to 1 Faraday. Then see here, 40 grams of aluminium from molten aluminium oxide, you have to calculate to deposit this much gram, we have to calculate how much electricity is required in Faraday. So molar mass of aluminium is 27 gram. Half cell reaction, aluminium plus 3 accept 3 electron and gives you 1 aluminium. So to deposit 1 aluminium, that means to deposit 27 gram of aluminium, 3 moles of electrons are required. So 1 mole of aluminium, that is 27 gram of aluminium, requires 3 moles of electron. That means 1 mole of aluminium, that is 27 gram of aluminium, requires how many Faraday? 3 Faraday of electricity. Therefore 40 grams of aluminium requires how many Faraday? In the same way you have to calculate. 27 grams corresponds to 3 Faraday. Therefore 40 grams corresponds to how many Faraday? So therefore 40 grams of aluminium requires 3 into 40 divided by 27. And that is equal to 4.44 Faraday. So like this you can solve the numericals based on the relation between Faraday and mass of the substance deposited at an electrode. So thank you for watching.